notes for 12.2, experimental probability. Your essential question is, explain whether you and a friend will get the same experimental probability for an event if you perform the exact same experiment but separate from each other. Alright, so what we're talking about with experimental probability is very similar to theoretical probability. It has the same formula, probability still equals the number of outcomes, or the number of times an event, and this time instead of can occur, it's going to be does occur. That's your keyword there. Over the total outcomes. So your probability is still exactly the same. The difference between experimental and theoretical is what you think should happen without actually flipping a coin or rolling the dice or spinning a spinner. Experimental probability is what actually happens when you do the experiment. Because they're different, because if I were to take this die and roll it 6 times, I'm not guaranteeing that I'm going to get a 1, a 2, a 3, a 4, a 5, and a 6 each time. We're just not that lucky. It's a game of chance. Probability is all about chances. So when you're doing experimental probability, you actually did an experiment, and you're doing the probability. You're counting up, okay, how many times did I roll a 1? How many times did I roll a 3? When you're doing your book, they'll give you the data. So for example, let's say we've got a spinner, or no, not a spinner, I'm sorry. We're looking at a sports game. It says, Josh recorded the number of hits his favorite baseball player made in each of 15 games. He organized his results in a frequency table. Okay? So we have the number of hits. We can say this is maybe Murphy and the Rangers. Okay, so this is, he got 0 hits, 1 hit, 2 hits, or, 3 hits. And then we can put how many he got. So this was our frequency. Frequency meaning how many times did he get, how many games did he get that many hits? And this is actually question number 2 on page 674 of your book. We've got 4, 8, 2, 1. 4, 8, 2, and 1. So there's our frequency table. And we can find the experimental probability that this baseball player will make 1 hit in a game. So what's the experimental probability that he made a hit of 1? Well, you first have to figure out how many total hits does he have. Well, 8 and 4 is 12, 13, 14, 15. So we have 15 total hits. And that makes sense, because didn't he have 15 games, right? I'm sorry, I misspoke. Not 15 hits. 15 games where he played. And then in 1 game, he got 3 hits. In 2 games, he got 2 hits. In 8 games, he got 1 hit. And in 4 games, he got 0 hits. So, what's the experimental probability that he got 1 hit? Well, it would be 8 out of 15. Probability of 1 hit. What would be the experimental probability that he hit the ball at all? Well, the only time he didn't hit the ball was right here in 0. So that means he hit the ball twice, he hit the ball 3 times. So 8, 9, 10, 11. So the experimental probability, because this is an actual experiment, that he made a hit is going to be 8, 9, 10, 11 over 15. So really the difference between experimental and theoretical for us in the classroom isn't really much difference. You're really just looking at the paper and seeing what happens. In theoretical, you just look at the object and you count. In experimental, you're being given experimental